So our second example. At the beginning of your second example, you should almost be like, woohoo, this is going to be easy. It's already factored for me. So that's a strategy. However, we have to remember that it's only helpful if it's factored if the other side is equal to 0. And the other side is equal to 5x. So unfortunately, the fact that the left-hand side is factored is actually more unhelpful than it is helpful. So we have to, in part A, start by multiplying out, right, doing your arrows and FOILing everything out. 2x squared, my outside is minus 2x plus x minus x minus 1 equals 5x. So we FOIL out the left-hand side. I did the outside and inside together and combined them right away. Are you okay with that? Okay. It's fine now that you're in grade 11 for multiplying out. If you can do it all in one step, perfectly fine. Now, I have some like terms, and I need to make one side equal to 0. Whether I'm using completing the square, factoring, or the quadratic formula, one side has to equal 0. So I'm going to move that 5x over, giving me minus 6x minus 1 equals 0. Okay. Which one might I go to? Can you see that if you use completing the square, you would first have to divide everything by 2, because you don't like that number in front. And you would already have a fraction at the 1/2. If you took out a 2, this would also become a 3. This is a lot of thinking ahead. But thinking ahead, that 3 is supposed to be your hint. And if that 3 is your hint for the squared, you'd get another fraction. And then when you squared, another fraction. So looking at this one, doing an analysis of it early, I would say that completing the square is going to give me a lot of fractions. I might be tempted towards the quadratic formula. Okay? I'm pretty good at factoring. I also did the quick look and figured out this one couldn't be factored. But sometimes factoring ones, when the number at the front is a 2 or a 3, those are harder ones to factor. So you can also go, even if it's possible to factor, you might say, I'm not good at factoring the ones where the number in front is like a 2 or a 3. Those ones are harder for me. So you might also then say, I'd like to use the quadratic formula. If you use the quadratic formula here, can you see that your A value is 2, your B value is minus 6, and your C value is minus 1. And now I can go directly to the formula. Negative 6 would be 6 plus or minus B squared, 36, minus 4 times A times C over 2 times A. This is just plugging things where they belong into your formula. X equals 6 plus or minus 36 plus 8 will be 44 over 4. We have to check our square root. Is there a perfect square you can pull out of there? What family does it belong to? And you see that that is your square root of 11 family. 4 times 11. So the square root of 4 is 2, so it'll become 2 root 11 all over 4. Then you have 3 terms. If this fraction can be simplified, then something has to be able to divide all 3 of them, and it is 2. So if I divide everything by 2, this will be a 3. This term will just become root 11 when I divide by 2, and this one will become 2. That is our final answer simplified. Whew, and the textbook even got full marks. So proud of it. Oh. Question B is a great example of don't just jump into a question. It starts off with 1/2 x squared minus 5 over 4x. And it has equals to 3, but I'm going to move the 3 already over to this side. Now, before you go and say, ooh, there's fractions, I don't want to complete the square, I'm going to go to the quadratic formula, be aware that if you go to the quadratic formula right away, you also have a as a fraction, b as a fraction. So it could be a little bit not nice in the quadratic formula either. But if we take a step back even further, and we say, if I have an equation, and what I do to one side, I can do to the other side, you can make this equation not have fractions. What would I have to multiply each term by to get rid of all the fractions? If I multiply by 2, I'd get rid of the fraction in the first one, right? But not the second. But if I multiply by 4, do you see that that would get rid of the fraction in the second one, but would also get rid of the fraction in the first one? So I'm going to multiply everything by 4. And you can show that if you want by putting brackets and say times by 4, and then, right, pull out your calculator for the right-hand side. 4 times a half, that will be 2x squared. 4 times negative 5 over 4 will be minus 5x. And 4 times negative 3, minus 12. And of course, 0 times anything is 0. Now, we can look at it again. Okay? Our 3 options for solving: factoring, completing the square, and quadratic formula. Okay? Factoring. You want to try this one? Is this one, when you look at it, do you feel like, oh, I'm confident I could figure this out factoring, or not quickly? So you might go, and this is the other thing about factoring. Factoring doesn't always work. So if you decide to go, I want to factor this, but it's not going to be quick, plus I don't even know if it's even possible, then maybe you would say, I'm going to not do factoring. Then, look at completing the square and quadratic formula. Can you see completing the square? You'd have to get rid of this 2, divide everything by 2, and it would give you a fraction of 5 over 2. So the completing the square in this one would have fractions. So I would say, most likely, a quick analysis of this one would tend to say the easiest thing for most people is the quadratic formula. Mr. Burnett doesn't know that some people teach. That's right, I'll have to hold him back. So our quadratic formula would tell me that A is 2, B is negative 5, and C is negative 12. And I plug things into the formula. Negative 5 would be 5, plus or minus. B squared, when you square B, it's always positive, 25, minus 4. A is 2, C is negative 12, over 2 times A, which will be 4 on the bottom. X equals 5 plus or minus. Okay, 8 times 12, 96, plus 25, 121. And can we simplify anything? This is perfectly 11. Whoa. Sorry, I have to make a happy face. That's perfectly 11, which is crazy, because this will give us easily a way to figure out both answers. Because you can add 11, you can subtract 11. What's 5 plus 11? 16 divided by 4. One answer, 16 divided by 4 would be 4. The other answer, if you subtract 11, 5 minus 11 would be negative 6. Negative 6 divided by 4, negative 3 over 2. I put the little happy face because when this works out to be a beautiful number that square roots perfectly, the happy face tells you could have been factored. It would have worked if we would have went the factoring method. How How do the answers tell us what the answers even tell us what the factoring is what I love about this. Okay, check it out. Bracket, 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 bracket equals 0. If one of my answers is x equals 4, what does this factor have to be x equals 4 as an answer? X minus 4. And then if that one's x minus 4, the only way to get my first one to be 2x squared, this would have to be 2x. Does that make sense? And the only way to get a minus 12 is if this was a plus 3. And look at that factor. If you made it equal to 0, do you see that you would have got negative 3 over 2? Sorry. This is so cool for me. So we could have factored this, but factoring it looked like it would be difficult. But once we found our answer, we're like, oh, now you can go back and it even tells you what the factors are. And you could be like, oh, would I have seen that? Check out your outside. Outside is 3x, inside minus 8x, makes minus 5x. Works out perfectly. Okay. So, questions 7 to 13, that's a lot. Circle them all. Those are all good examples for practicing. And I'll leave you with that for your super long weekend.